So far we talk about confidence interval estimation of coefficients of intercept and the slope, right? But we really don't talk about how actually y and x, right? Because we want to look at y and x are related, right? So most often what we want to do is, given some value, a new value of x, we want to predict a y, right? Because that's the reason why we want to figure out the relationship between x and y, right? For example, as application, we in the beginning example, we talk about education and income, right? And that is the what we want to know is looking at the relationship between education and income. We want to know what is the return of education, right? And we want to say, oh, is it worth to spend more time in the college or study a master degree and a PhD and a doctoral degree, right? That is the idea. So the first thing we want to talk about here is talk about the mean response, the mean of given x. We want to find the mean of the y, and we want to give interval estimation and hypothesis testing, right? So the first thing we want to take a look is the point estimator, right? For the mean of y given x is x0, right? So that is very simple, right? Looking at the regression equation will be the alpha hat plus beta hat but x0, okay? And we will show in the next few slides the variance of this estimate, okay, will be sigma square times 1 over n plus a fraction, which is x0 minus x bar over sxx, okay? And you can easily see that this variance will be very small, right? When x0 is equal to x bar, right? It's actually smallest when it's equal to x bar, and it become bigger when you deviate different from x bar more and more, right? It's square, so no matter you go to the left side of the x bar, right side of x bar, it's getting bigger and bigger, the variance. And the standard error will be just take the square root and replace sigma square by s, right? The which is the estimated from the residual. Okay, so now we'll try to explain why the variance is like this. So just again we use the same shorthand sxx, right, with the sum of square on x, and the variance of what we want to do is alpha hat plus beta hat x0, right? And we use the variance covariance formula. Will be variance of a plus variance b plus variance a covariance ab, okay? And variance of alpha hat will be just follow from previous slide, right? Sigma square sum of xi over n sxx, right? And x0 is given, right? Because we know this value, and this is beta hat, right? Will be sigma square of sxx, and the covariance of alpha and beta hat, okay, will be given by x bar sigma square over sxx minus. So we will prove this in the next slide, okay? Let's take it for granted. And now here is summation xi square, okay? You can rewrite it by sxx plus nx square, okay? Because sxx is minus, you can replace it by minus xi x bar, right, plus x bar square, right, and calculating the square. So you cancel out some manipulation. Simple manipulation would be nx square, okay, and this cancel out is 1 over n, right, and n cancel is x square, and you can easily see that it's a we complete the square will be equal to this one, okay? And what remains is to show covariance of alpha hat and beta hat. So to do it, let's look at rewrite the alpha hat, right? Y bar plus x bar and beta, right? And beta is this guy, right? Is sxx as a denominator and xi minus x bar yi, right? You can have y minus yi bar, put a y bar, but doesn't really make a difference. Okay, equivalent form here. So the covariance, right, is alpha beta, right? So it's rewrite what is here, right? Here I just take out the summation here and yi out, right? Same here. And okay, because yi and yj are uncorrelated because epsilon I, epsilon j are unrelated, right? So that's why you can just multiply each. So this multiply this and this multiply that, right? And yi, the covariance yi will be sigma square because just the random term is just the epsilon. And this multiply this, right? And this multiply this, right? So the square and x bar. And look, this is a fixed independent of n, right? This is x minus x bar. Some of them will be 0, right? And this become sxx, right? So cancel out will become negative x bar sxx sigma square. So that's what we have claimed here. So now we prove this variance. Okay. Now with that, it's easy to construct the confidence interval estimation, right? And then you can do hypothesis testing as well. But we want confidence interval in this case. So this is a point estimate, and the width interval will be again same as the t's and u plus the e, right? The same thing here. Okay, so that's end of this part.